Hello, welcome back. So let's talk about storage device management, right? So when we talk about this, uh, usually we would format the disk first. Either we use low-level formatting or physical formatting, and we divide the disk basically on some kind of partitions, right? To use the disk, basically, we would divide the disk into partitions. Uh, and later into logical formatting, which makes into file systems, right? Uh, Now the root partition basically contains the operating systems. Other partitions can hold other operating systems, file systems, or can be a raw partition that keeps data, right? Now these partitions are basically mounted when you boot the machine, right? The operating system, right? When you boot the operating system, right? Other partitions can either be mounted automatically by the operating system or manually mounted. So during the mounting of that particular partition, file system consistencies are basically checked to see that whether the table for the partitions are correct, right? So if you look into a raw disk, basically the disk would have a couple of partitions, right? One disk can have about 4 partitions, right? About physical partitions. At the very top of it, it has a NBR, which is called the master boot record. The master boot record basically keeps into information as the boot code that's required and the partition table for it to find the operating system, right? Where the operating system. So when you complete the boot, basically, first the BIOS takes over. The BIOS would look for the MBR, right? And right. So after that, basically the BIOS basically provides the bootloader to find the MBR, and it will find the boot code that would boot the operating system, right? So the boot code would find the boot partition and to allow it to to either run Windows or Linux per se. Now in every hard disk as well, there's sometimes allocated swap partitions, right? So swap partitions are common in Linux operating systems. Okay. Now, storage system can be attached either by directly to the host via the network or via the cloud, right? When it's connected to the host, it's attached to a local I/O port. For example, USB, FireWire, Thunderbolt, right? Or in some cases, in other high-end servers and machines, we have fiber channel, right? Fiber optic channel. For example, there are other storage that's called a NAS, network attached storage, are usually attached to the host via fiber channel, right? So it can sit anywhere in the LAN or WAN, right, and can be accessed by client, and they usually attach to the WAN via fiber channels. Similar to NAS, there are also cloud storage, provide storage in the network. Unlike NAS, this actually goes over the internet on the WAN, right, to remote data centers, right? So, for example, Dropbox, Amazon, Microsoft OneDrive are all cloud storage. Right? Besides that, there's also a term called storage arrays, right? Which means basically just array of disks, right? So which allows you to have multiple hard disks arranged in a way, right? So if you look at this, a SAN storage software array network, which has a bunch of storage arrays that you can keep. Will be connected to servers for data processing, web content provider, and some other clients. Right. Storage area networks are pretty popular. There are several options by manufacturers. HP, IBM provides specific storage array networks, right? And they have specific fiber channel connecting those to the host, right, or to the network. Now, one of the most important thing in hard disk configuration is called a RAID structure, right? A RAID is basically the idea of a redundant array of inexpensive disks. So you can combine a bunch of disks together and basically create a redundant array of inexpensive disks called RAID, right? Now there are many reasons why you want to have this. One of the reasons is basically, increase the size of storage that you can keep. The second is multiple disk drives provides reliability by providing some kind of redundancy, right? It also increases the mean time to failure. So if you have a lot of disks, you can access them less frequently, for each disk. So you can consider some data is kept in disk 1, some data is kept in disk 2. So if you access them equally in that sense, your lifespan for the hard disk increases as well, because you don't access the disk as often, right? And therefore also it increases the mean time for data losses and mean time for failures in that case. So when we're doing this thing of keeping data in a RAID structure, because there's more than one disk, one of the idea is a disk striping, which uses a group of disks as one storage unit, right? So we have a bunch of disks, we can stripe it, and we use a bunch of disks as one storage unit, right? RAID there are many levels of RAID depending on how it's being arranged, or the method is keeps or combine these multiple disks, right? So at the very first one that is commonly used is for redundancy, and we call this RAID 1, right, which provides mirroring or shadowing, right? Basically it duplicates each disk. So if you have one disk, it will duplicate on the other disk, right? This basically provides very high redundancy, because if one disk fails, basically you still have one disk that you can count on, right, that has a mirror, right? The other thing is the other thing that it provides is stripe mirrors, right? Okay, sorry. If we actually stripe the disk by putting data in multiple hard disks, and at the same time mirror it, we call them RAID 10, or mirrored stripe called 01, right? There are other levels of RAID 4, 5, and 6, which uses less redundancy, but other advantages as for striping, right? So let's look at this idea here. So RAID 0 is basically a redundancy, so basically it's non-striping, right? So we consider striping here in RAID 1 with mirrored disks, right? So if we're not this is RAID 1, right? And if RAID 4, 5, and 6 provide different types of redundancy by using parity bits. So we can see 4 hard disks can provide redundancy by just calculating the redundancies of the bits, or block interleave, so we can keep those parities in different sectors, or two different redundancies, right? RAID 6, right? Using parity, right? Okay, so what's the difference between RAID 0, 1 and 10? RAID 0, 1, right, Basically, first it has it stripes and then it mirrors. When we say stripe, basically we we keep data across multiple hard disks, right? So if suppose you're keeping the word data, so D would be here, A T A, right? So when we're accessing this is you don't actually accessing one disk, you're accessing four disks, right? So when we have RAID 0, basically we stripe it out and then we mirror it, right? And the other method is 10, where we mirror it and then we stripe it, right? So there's slight difference there, right? Regardless of where the RAID implementation, I know RAID is actually a good thing to have. It does duplication, provides snapshots and etc. Right? And usually, it allows decreases the time that mean time for you to do any repairs. Right? I'm gonna skip some of this extension part here, right? And move to okay. So we're finished, much finished, right? So I might be providing more information about RAID here and this scheduling for chapter 10. And if you have time, please read through the book and slides as well, right? To prepare for incoming examinations and etc. All right, so I'll see you again in chapter 12. Hope to see you soon.